Hello and welcome to today's tutorial video on how to name and write formulas for ternary ionic compounds. And what ternary means, before we talked about binary ionic compounds, here ternary means that you still have ionic compounds, they just have more than two elements present. Binary means two things, two elements in this case, so ternary I just see more than two elements present. I still have cations and anions because that's what I need to have an ionic compound. But now the thing that's different is they are going to involve polyatomic ions. And what polyatomic ions are they are ions that have multiple atoms joined together. When they are joined together, we treat them as a singular unit, which means I cannot change the formula of those ions. The formula is fixed. They have their own charge and their own name. We don't need to worry for right now about how they get the charges that they do, but we do need to familiarize ourselves with the names of some of these polyatomic ions and what charges they do carry. Most of the polyatomic ions we see are anions. However, there is one cation that we see and use quite frequently. So here's a table of some common polyatomic ions. This table is in your book. There's also multiple reference tables available on the internet. So if you don't know the formula of a particular polyatomic ion, you can sure look it up, but this is a good place to start. So you can pause the video at any time and come back to and review this table. I see the one positive ion here, the positive polyatomic is ammonium, which is NH4 with a plus charge. So pay attention to these formulas, start getting familiar with these names and what charges they have, and we'll do some examples here. So first I'm going to write formulas that have polyatomic ions in them. So I have a name of a compound such as magnesium hydroxide, and my first clue that this involves a polyatomic ion is that it's hydroxide. It's not oxide like we've seen before. Oxide would just mean that it's oxygen. Hydroxide means that it's different. There's something new here. So magnesium is a +2 charge. I always know that. Hydroxide, I might have to go back to the previous slide and look it up, but the formula is OH, and it has a -1 charge. Together, that polyatomic ion has a -1 charge, so it gained 1 electron. In order to make my formula neutral, I need 1 magnesium ion, and I need 2 hydroxide ions. So my formula is going to be Mg, and I'm going to use parentheses to indicate that I have 2 hydroxide ions. And that distinction is really important. If you have more than one polyatomic ion, you need parentheses in your formula. Otherwise, if you just have one, you don't need parentheses. I'm going to do another example like sodium phosphate. Sodium is a +1 charge. Phosphate, I have to look up on my table. Phosphate is a -3 charge, and its formula is PO4. In order to make this balance out to 0, I need 3 sodium ions, each with a +1 charge, and 1 phosphate ion with a -3 charge, and so my formula becomes Na3PO4. I do not need parentheses here around the PO4 because there's only one of that group. There's only one PO4 ion that's in my formula, but I do need the subscript of 3 next to sodium. Okay, let's see some formulas and let's write the names from those so we can recognize the polyatomic ions. So I have something like NaNO3. I need to recognize that NO3 is the polyatomic ion and its name is nitrate. Na I should be familiar with, that's sodium, and so I just name it exactly what we were doing before. I name the cation first, which is sodium, and then I name the anion second, which is nitrate. So the name is sodium nitrate. Here's another example. I have Ca, and then in parentheses ClO3, parentheses 2. I need to recognize the ClO3 minus as the chlorate ion, and so it has the name chlorate. The little 2 next to the parentheses indicates that I have 2 of that ion because calcium had a +2 charge. So my name for this compound is calcium chlorate. So here's some examples. You can pause the video and try these on your own right now. Refer to a table of some common polyatomic ions. And when you finish, I will reveal the answers for you, and you can carry on with your own practice. Okay, so now let's see the answers to the practice problems that you just did. Ammonium chloride. Ammonium is NH4 with a +1 charge. Chloride is a -1. So +1 and -1 are going to balance out. I get NH4Cl. My next example is aluminum carbonate. Aluminum is a +3. Carbonate, the formula for that is CO3 with a -2 charge. So I need to add a couple more of each kind here. I need 2 aluminums altogether and 3 carbonates altogether. So my formula becomes Al2 parentheses CO3 3. Potassium nitrate. Potassium is a +1. Nitrate is a -1. So those are pretty easy to balance. I get KNO3. Iron 2 sulfate. This is a transition metal. So the 2, remember, tells you the charge on iron. Iron is a +2 then. And sulfate is a -2 charge. So I get FeSO4. No parentheses needed there. Let's go into naming these compounds down here. So I see NH4OH. I actually have 2 polyatomic ions in this compound. NH4 is 1 and OH- is 1. So the name of NH4 is ammonium, and the name of OH is hydroxide. MgSO4. Magnesium is not a transition metal, so I do not need Roman numerals. SO4 is my polyatomic, so I have to recognize the name of that as sulfate. So my name becomes magnesium sulfate. And this last one is kind of tricky because copper is a transition metal, which means I'm going to need Roman numerals in my name. If I draw my picture, I have 1 copper ion and I have 1 carbonate ion, and I know the charge on that as being -2. So that means copper must be a +2. So the name of this compound is copper, Roman numeral 2, carbonate. Okay, do some more problems on your own, and we'll see you back in class the next day.